Ever notice how some plastic toys survive endless abuse, while others shatter at the first drop? It's not magic. It's all about the type of plastic. One plastic bounces back, another cracks. The difference is in the material's DNA. In injection molding, picking the right plastic is everything. Think of it like baking. You wouldn't use cake flour for bread. Plastics are just as varied. The wrong choice leads to broken products and wasted money. So, let's become material detectives and explore the plastics that shape our world. We'll see why polypropylene, ABS, and polycarbonate each have their place. By the end, you'll know how to spot the right plastic for the job. Let's meet the plastics you use every day. Polypropylene, or PP, is the workhorse, found in storage bins, chairs, and food containers. It's flexible, chemical-resistant, and cheap. ABS is the builder's favorite. Think Lego bricks, tool housings, and car dashboards. It's strong, rigid, and looks great. Polycarbonate, or PC, is the tough one, used in safety goggles and helmets. It's clear and nearly unbreakable. Each has its quirks. PP can warp, ABS hates moisture, and PC is sensitive to stress and scratches. Get the process wrong, and even the best plastic can fail. Pros know these risks and design around them. The right plastic makes all the difference. That's why material choice is the first step to a successful product. Let's dig deeper into what makes each one unique. In the factory, PP is perfect for cheap, durable items like cups and bins. It's flexible and chemical resistant, but sunlight makes it brittle. ABS is the go-to for premium glossy products, electronics, remotes, and car parts. It's tough, but absorbs moisture, so it must be dried before molding. Polycarbonate is for safety gear and barriers. Impact resistant and clear, but tricky to mold, and prone to stress cracks if mishandled. Each material is a trade-off. PP for flexibility, ABS for looks and strength, PC for ultimate toughness. Good engineers know these strengths and weaknesses. They design parts and processes to avoid common pitfalls. That's how you get products that last. Choose wisely, and your plastic part will do its job for years. Now, for the heavy-duty plastics nylon and POM. Nylon is tough, slippery, and perfect for gears and bearings. It resists wear, but absorbs moisture, which changes its properties over time. POM, or Delrin, is even more precise. Great for clips, fasteners, and moving parts. It holds its shape and resists fatigue. Nylon needs careful drying. POM needs precise temperature control to avoid dangerous fumes. Choosing between them depends on whether you need ultimate toughness, nylon, or perfect stability, POM. These materials are for parts that need to work millions of times without fail. Get the details right, and your product will run smoothly for years. That's the power of engineering plastics. Polyethylene, or PE, is everywhere. Bags, bottles, bins. LDPE is soft and flexible. HDPE is rigid and strong. Both are cheap and chemical resistant. Their weakness? Low melting points. Don't use them where it gets hot. Material choice matters. Pick the wrong one, and your design can fail spectacularly. A rigid plastic in a snap fit? It'll break. The right material bends and holds. Changing plastics mid-project can ruin fit and function. That's why smart engineers choose materials before the first mold is made. The right plastic saves money, time, and headaches. The biggest mistake: focusing on one property, like strength, and ignoring flexibility, cost, or processability. Great products balance many needs: strength, flexibility, cost, and how the part is made. Work with your factory team. They know what works in the real world. Quick recap: PP for flexible items, ABS for strong housings, PC for toughness, nylon for moving parts, POM for precision, PE for cheap containers. Each plastic is a tool. Pick the right one for the job Understanding these basics is the first step to better products. Next time you pick up a plastic object, think about why it was chosen. The more you know, the better you'll build. Now, go make something awesome.